Hello. So we are starting Unit 7 today. So just a heads up about what Unit 7 is about. There are 3 lessons in your textbook that are on Unit 7. The first lesson is just, as it says at the top, data and variables. So it's about data and how do we gather data. So that's what Lesson 1 is going to be about. Lesson 2 is going to be about how we represent data. So once we've gathered all the data, how do we then represent it to people who are wanting to look at the data? And then lesson number 3 is going to be how we deal with calculations of data. So we've gathered the data, we've represented the data, and then how do we start calculating or making inferences from the data? In other words, when we start talking about statistics. So first things first, with this lesson, we're going to talk about data and what is data. So we've got this general umbrella of an idea of data. And our first subcategory of data is quantitative versus qualitative. So quantitative kind of, and qualitative. Okay, so we've talked about this before. I'm sure you've talked about it before. The main idea with quantitative is that there is a number sense to it. It is numerical. Okay, so it's a numerical type of data. Qualitative is something that you can put into categories. All right. So when you're trying to think about what is quantitative versus what is qualitative, I want you to start thinking about, can I put this into a category? So if we're talking about preferences for gelato or granita, if we're talking about hair color, if we're talking about boys versus girls, there will still be numbers associated with it, right? There will still be 2 people who like almond granita, okay? But there won't be, you're separating it into categories. So while there are numbers associated with it, it is not quantitative, it is still qualitative. All right, our next subcategory is sub-underneath quantitative. So after we talk about, okay, this is quantitative, you go down below and then there's 2 different types of data that go under quantitative. They are discrete quantitative data and continuous quantitative data. Discrete data is data that is counted. Typically, these are whole numbers, right? If we're counting something, we're saying, okay, there's 12 people who would be under this category, or there are 13 pencils that are red, right? We don't normally say there are 13 and a half pencils that are red and 13 and a half pencils that are green, right? So we talk about them as a whole number, and that's discrete. Versus continuous is something that you measure. So it's measurable data. So if you try and think about this as height or weight or time, right? You can have 13 and a half minutes. You can be 130.2 pounds, right? So all of those are continuous. There's not specific countable whole numbers that go into it. Okay, so let's just practice this. Let's categorize the following points of data. The first one, we've got a cigarette that contains 16.3 milligrams of tar. So this is measuring, right? We're measuring the amount of this substance in a cigarette. So if it's measurable, then it's quantitative and continuous. All right, there were 15 females and 21 males in the statistics course last term. While there are numbers, since we're separating it into categories, that means it's going to be qualitative. Next, major earthquakes happened in this year, this year, this year, this year, and this year, right? So we've got 5 different years that we're talking about. Since it's only one piece of information and it's being counted in specific segments, this is a discrete quantitative. Notice with this, we're focusing on one thing, major earthquakes, right? Whereas qualitative might be focusing on multiple things, yeah? So since we're focusing on one thing and that one thing occurring at these different points in time, that makes it a certain discrete and quantitative information. All right, the average rainfall in Rio de Janeiro for the first 6 months of the year, 114, 105, 103, and it goes on. We are measuring rainfall. You can have 0.5 millimeter of rainfall. So this is going to be measurable, so continuous, quantitative. Upon completion of training for his upcoming bicycle race, Mr. Coelti's mass was 326 kilograms less than when he started. So this is a measure of mass being lost, and I'm sure it's compared to other points of data of mass. So we are measuring weight, right? So if it's measurable and it's continuous, and while it's only one point of data, it is still a data point that is quantitative and continuous. All right. Now this one is a little tricky. If we're talking about zip codes or postcodes of a country, this is qualitative data because those numbers don't really tell us anything. It's not like Novorossiysk is the zip code of 20090, but it's not telling us that there are 20,090 people in the city. It's not telling us that we are 20,090 kilometers away from something, right? It's not telling us anything. It's just a category that has a number associated with that category. So since it is this idea of you are all put into this category of this certain area, it is a qualitative piece of data. All right, so overview of what are the different parts of data or different things of data that go into what we're talking about. So the next thing we're going to talk about is what is a statistic / what are statistics. So we're going to draw a little picture. With statistics, we start first with a population. So we've got this amoeba of a population. And we could have different points of data within this population. They could be different things. We've got the general overview of a population. And the definition of a population is the complete collection of all elements to be studied. So we've got our complete collection of all the elements that we want to study. We might have something that we want to talk about. We're going to have a total population that represents everybody who could possibly fit into this idea of what we want to talk about. And then from there, we're going to say, well, it's too much to grab all of the information from all of the populations around. It's going to take too much time. It's going to be a waste of time. When we could just grab a smaller subpopulation, a subgroup that we call a sample. So we gather this smaller group in order to study this smaller group. So your sample is a sub-collection of elements from a population. The second half of these notes that you're going to watch for homework next time is going to talk about how do you gather a sample. There are so many different ways of how do you gather a sample, how do you gather it if it's biased or versus not biased, how do you gather it if it's random or not random, which one's the better one. We're going to talk about all of those later. But the idea is you take this amoeba of a population and you create a sample. The hope is that this sample is a perfect representation of your population as a whole. It's a little bit easier to digest. It's a little bit easier to understand and to interact with and gather data with if you've got a smaller subset. So in order to go, and this is our sample. In order to go from a population to a sample, we first have to think about what our parameters are. So the parameters are the limit or the boundary that describes the scope. Of the process that we're going to go through. Right? So if I wanted to challenge somebody to a dance competition, the parameters of this of this process is going to be that we are competing in a dance competition. Or if I wanted to study the effect of a late lunch versus an earlier lunch on retention of material, that would be the parameters of what we're doing. Okay, so I'm going to use this idea of, okay, I've got this population that I want to study. I've got this idea of what I want to focus on. I'm going to take that idea of what I want to focus on to then create my sample, whether it's truly random or not, and we'll talk about all the different ways, but we have to keep in mind what the parameters are in order to then create our sample. From there, once we've created our sample, we need to take a long, hard look at what is going on in that sample. We gathered the sample, we start gathering the information, and then we really truly investigate that sample. The investigation of that sample, whether it's the measuring of the data, it's making inferences from the data, that is what we call statistics. Okay? So the main goal of gathering of your data, how do you make a sample? How do you represent the data that you found? All of that leads to the ability to then do statistics. So let's write down the definition. Statistics is a numerical characteristic of the sample. So we use this numerical characteristic of only the sample to then make inferences of what's going on in the population. Will it always be true? No, but that's the hope. That's what we are always striving for, is for whatever we find in the sample to be true for the whole population. Every once in a while, you might have a piece of data that sticks out from the rest. You don't notice it. It doesn't fit in with anything else. It isn't truly really a part of the bigger population. Maybe we'll have like one circle in the population. But to have one circle in the population and then one circle in the sample doesn't really accurately describe what's going on in the population. So sometimes you have this one piece of data that's a little bit distracting from the rest of the data. And we call this an outlier. Now, is it still a true piece of data from the population? Absolutely. But sometimes when we use that piece of data in order to make inferences for the population, it could misrepresent what's actually going on in the population. We're going to talk a little bit later about what actually is an outlier and what statistically and technically and mathematically qualifies something to be an outlier later. But for right now, we can think of it as a singular piece of data that distracts from the rest of the data. And that is pretty much what statistics are. It's